Okay, here we go. So this is section 7.2 again for Algebra 2. This is DL10. I believe we're on DL10. Okay, and what we're practicing today is changing from y equals ax plus b over cx plus d form to y equals a, well, we won't call it a. We'll call it capital A, I guess, over cx plus d. Well, that's not really how it, well, I guess so. So cx plus d plus some other number over here. We'll call it plus e form. Okay, so what we're going to do is we're going to long divide. Oops. Okay, so we're going to long divide. And we have to remember the steps of long division. So the steps of long division, step number 1 was try to think of a number. I called it equal sign, actually. We were trying to equal the number. The number sign is if we're in elementary school. So this is our long division steps. And then multiply. And then subtract. But what we really did was change signs of bottom row. And add. And then 4 was arrow, which means you go, you bring it down. So that was step 4. And then you repeat and you go back up. So let's remember by looking at a question. So for example 1, we have f of x equals 2x plus 1 divided by x minus 3. And we want it to look like the ones we did yesterday or the day 2 days ago. So we want to see what we did. And so what we're going to do is we're going to change it probably to y equals. And then we're going to put the x minus 3 in the front of the long division sign. And the 2x plus 1 on the inside of the long division sign. And then we're going to write our steps. The more times we write the steps, the more likely we are to remember. So equal sign, multiply, subtract, and bring down, and then repeat the steps. In these often, though, you just have to do it once. So the repeating the step isn't really true for these. So what you need, what we did first is we double underlined the first letter, and we double underlined the first object in the divisor. The divisor's in the front, and in the dividend, which is in the middle. And what we were trying to do is we were trying to make it match. So write in the comments if you know how to get from x to 2x by multiplication. So I want to know what number am I putting at the top. I'm trying to figure out. So it's 2. So you're going to multiply the 2. So you put the 2 at the top. You're trying to figure out how to make a match. And then you distribute this to both. And I get 2x minus 6. So I multiplied to the front. So you distribute. And then the minus sign is you subtract them. But to subtract them accurately, usually what we do is we change the signs and add. So you're distributing the negative sign throughout the bottom, which is after the subtraction. And then you add them, or you combine like terms. So this cancels. If that doesn't cancel, something went wrong. And then this is 7. And then you can't make an x into a 7, except maybe to multiply by 7 over x or something like that. So we're kind of half done, but we don't know how to write the answer. So with long division, I'm going to remind you in a different way up here. But basically, when I long divide a number, so I'm going to long divide a number over here real fast. So we try to find out how many times it goes in. We multiply, we subtract, we bring down. We think of a new number, multiply, subtract, and to make the fraction at the end, The denominator will be the number in the front. And the remainder always goes at the top. So the 5 comes from the number in the front, and the remainder goes on top of the fraction. Now, the only difference with what we do with the algebra is we put a plus in the middle, because in algebra, if you don't put a plus, it means multiplication. So that's why I put the plus. Okay, so what would go on the numerator? What goes on the top of the fraction in the one that we did, in this one right here? So what goes in the numerator, the top of the fraction? What do you think? So this one, the 4 went on the top of the fraction. So in our problem, in what I boxed in blue, what goes in the top of the fraction? Yeah, exactly, a 7. So the 7's gonna, oops, except I'm in erase. So let me unerase that. Okay. Okay, so the 7 goes in the numerator. And then what goes in the denominator of that fraction? What's the equivalent of the 5? So what would be in the denominator? Almost. So it's the whole x minus 3. So it's the whole term that's in the front. Okay, and then that looks funny. So I'm going to write it that way just because that's the answer I got. But that 2 looks funny to me. So the way that it looked yesterday is it was 7 over x plus, or x minus 3, and then a plus 2 at the end. Okay, so we're going to switch those around. The plus and the 7 over x minus 2, it goes in the front, and then this 2 over here goes in the back. So I'm just switching the order so that it looks like what we were doing yesterday, or on Tuesday. Okay, so then we need a basic graph. Before I do the basic graph, though, I'm going to write what the things do. So this outside part, the 2, do you remember which way that moves it? Yes. So this is going to move it up 2. And then what about the 3? Yep. So this is going to be right 3. Perfect. Okay, and then my basic graph, what I kind of do is I eliminate the things that I just looked at. So I kind of eliminate the minus 3, and I eliminate the plus 2, and I rewrite what's left. So what's left is y equals 7 over x. And you do need to leave the numerator in the problem because we haven't done anything with it. That 7 is a vertical stretch, but I don't like to do vertical stretches separately. I like to do them within the basic graph. It's my personal preference. Okay. So then I'm going to make a table. And this is a normal table, so we'll just use -2, -1, 0, 1, and 2. And then it kind of looks like the boomerang graph. So remember, at the end, we wrote asymptote at y equals 0. That's for the basic graph. This is for 7 over x. If it was different than 7 over x, for my basic graph, the way that I'm going to show probably on next week on Tuesday, is that it would look different, and it would the asymptotes will be different. So I'll show you how to find the asymptotes first. Okay, so for this one, that's 7 over -2. I don't really know what that is, so I probably would just not do that one. I mean, it's -3.5. Like, I'm a math teacher, so I know. But if I didn't have a calculator, I'd probably just leave it. 7 over -1 is -7. 7 over 0 is undefined, so I write asymptote in my chart. And then 7 over 1 is 7. 7 over 2 is 3.5, but I might just not do it. I might just graph these two and remember that it looks like a boomerang. So perhaps with those 3 points, that's all I need, and knowing that there's another asymptote. So we'll see. 7's kind of high. But I can make a graph that's 14 tall. Today we only have 2 examples. So maybe we can just use a whole bunch of graph paper. Okay, so -1, -7, 1, 7, which makes sense that this is a vertical stretch. And then my asymptotes are the yellow and the blue. So every basic graph that's like a boomerang like this, that's in that format, is going to have those 2 asymptotes to start with. And then I can sketch in my graph. So this is like a first quadrant, third quadrant graph, except I probably shouldn't have made it solid. I probably should have made it dashed. Right, because this is I just change colors. But it's sometimes hard for me not to graph it for real. Okay. So once I have that done, this is 7, so I should probably mark that I went up to 7 and down to -7. And then I'm going to move my asymptotes. So my yellow asymptote, I need to move right 3 and up 2. But when I move the yellow to the right 3, it's still the same asymptote. But when I move the yellow up 2, it goes in a new position. I'm going to change that to green. This would be my up 2 asymptote. That's 2. And that's y equals 2 for my horizontal asymptote. So since I have to label it, I might want to label it right when I do it. And the blue asymptote has to be moved right 3 and up 2. So when I move it up 2, nothing happens to the blue. But when I move it right 3, it comes over here to 3 and makes my new asymptote, which kind of looks like a new XY axis. So something I've never shown you guys before is when I actually do the graphing with the basic graph, if I have that point like 1, 7, I just go from my new origin. So I'll show you right now. It's kind of cool. So right here, I kind of consider that big yellow dot that I just made. I don't know if you can see it. Maybe. Yeah. So see where my green axes intersect? I think of that as my new origin, and then I go 1, 7 from it. So 1, 7 from like my new axis. But you don't have to do that. You could just move the point that you had. What, right 3 up 2? That's probably easier. Look, right 3 up 2, I get to the same spot. And then this is my green one, so I'm going to trace this one in. So this would be my graph. And then the other one is what? Right 3 up 2. Right 3 up 2 is right there. And then I'm supposed to make the, oh, I wish I knew where it hit the X and the Y axis. Because I'm about to go right through the middle and I'm going to be guessing. So we're going to find the intercepts on this. I don't really know where to graph it. So I'm good here on both of these sides. And I know it's going to go in, but I just wonder, what numbers is it going to hit? I could graph it negatives or positives or anything. So I'm going to find the intercepts on this one. Oh, and then let's write X equals 3 as my vertical asymptote. Remember, X equals for verticals and Y equals for horizontals. Okay, so I'm leaving the green missing because I don't want to guess where the intercepts are when I can actually find them in the equation. So let me see the equation. Y equals 2x plus 1 over x. Okay, so you have 2 choices. I usually go back to the original, 2x plus 1 over x minus 3. I don't usually go to the long divided one. I just go back to the original. So to find an x-intercept and to find a y-intercept, I'm going to write use original for intercepts. Okay, use the original for intercepts. Okay, so x-intercept, y-intercept. Okay, and let me zoom in on the graphic. You still need it. Okay, how do you find an x-intercept? How do you find an x-intercept? That's exactly right. So y equals 0. So you're going to substitute 0 in for y in this equation. And then the y-intercept, you're going to substitute x equals 0 into this equation. And there's two x's, so you're going to substitute the 0 for both of them. So I'm going to put a 1 underneath the 0 and cross multiply. So 0 times x minus 3 equals 1 times 2x plus 1. So 0 equals 2x plus 1 if I distribute the 1. So minus 1, minus 1. Negative 1 equals 2x. Divide by 2, I get x equals negative a half. And that is negative a half for x and 0 for y. Now, I don't think that's where I was going to put it. I was going to go positive. My green was not going to hit at negative a half, 0. So negative a half, 0 is right here. I definitely was not crossing at that point. I was definitely crossing in the positive land. Okay, and then this one is y equals 0 plus 1 over 0 minus 3, 1 over negative 3. So 0 comma negative 1/3. Okay, so I can just keep going. 0, negative a third. And now I know where they actually cross. So this one is the y-intercept. I'll label it, so I'll circle it. That's the y-intercept. And then this one, let me go up. This is the x-intercept. Okay. And then make sure you graph the rest of the green graph. So I did cross at negative a half and negative a third for the y-intercept. And then let me know when you're done so I can go to the next example. Okay, so in this lesson, the importance isn't that you have all of this perfect, but the importance is remembering how to find an x-intercept of any equation, y-intercept of any equation. We are also learning how to graph the boomerang graphs or the 1 over x graphs, the 7 over x graphs. They don't really have a name. I should check with some other teachers and see what they like to call them. They're called rational functions, but there's lots of different types. But that's not as important. If you didn't remember that, nobody would be too upset with you. Long division is important, though. So if that ever comes up, then you want to remember that. It used to be taught in Algebra 1, and now it's only taught in Algebra 2. So then you've only done it once, where usually teachers are used to students having done that twice. Okay, so let's do our next example, which is kind of the same. And for this one, let's find the intercepts first. We don't have to, but might as well. And then some of our example problems today will only be finding the intercepts, and then some will be finding the intercepts and graphing. Okay, so step 1, we'll call it find the x and y intercepts. How about we call that A? This is example 2. And then B is use long division to change to y equals a over x minus h plus k. These are sometimes the letters they use. Form. And then graph. And then label the asymptotes with their equations. Okay, so A says find the intercept. So x-intercept, y-intercept. I like to label them separately with a line in the middle, because if I don't, sometimes people combine the coordinates that they got from the x and the y, and they make it 1 point instead of 2 points. So I like to put the line in the middle and make sure we know that it's separate. And I always put the y equals 0, x equals 0 on there, number 1, so I remember when I'm doing the coordinates. but also because that's basically telling me how to do any x or y-intercept any graph it gives me. So now this one doesn't really say y equals, so I'm going to change g of x into y. So y equals 3x plus 5 over x plus 1. So that 0 equals 3x plus 5 over x plus 1. And then for the y-intercept, you're going to keep the y, but put 0 in for the x locations. I like the y-intercept better, so usually when I'm doing it myself, I find that first. So 5 over 1, which is 5. Oh, that's a nice coordinate. So 0, 5 is the y-intercept. That'll be a nice one to graph. Much more difficult to graph the fractions. And then this one, to solve proportion, I'm going to cross multiply. And then I get 0 times x plus 1 equals 1 times 3x plus 5. I don't usually show that step when I'm doing my own work. I usually just multiply it in my head. But then I always think it's weird that the x plus 1 disappears. And so sometimes I just would prefer to write it with the 0 times. And then it just, it doesn't seem like it disappeared. It seems like I actually did something with it. So minus 5, minus 5. Minus 5 equals 3x. Divide by 3, divide by 3. X equals negative 5/3. And that's the x coordinate. And the y coordinate is back up here, which is 0. So this is my x-intercept. Now, if I really want to graph that x-intercept, I'm going to need to know where negative 5 and negative 5/3 is. So I'm going to do a little division, 3 into 5, 1 time, multiply, subtract, and then the fraction would be 2/3. So 1 and 2/3. So negative 1 and 2/3. I should type it into the calculator and get a decimal. A decimal would be negative 1.666. Okay. Okay, so part B. Part B says use long division. Okay, so which one goes in the front of the long division sign? Which one goes in the front and which one goes on the inside? So let's start with the front. Which one goes in the front? So look up at the previous example so you could see which one you think goes in the front. Yes, so the x plus 1 goes in the front. And don't worry if it takes a little time for you to think of the answer, because otherwise I'm just speeding through and not really going on the pace of my students. So I appreciate you being here. It makes my pace better, so people don't have to pause me. Okay, so the steps of long division. So step 1, step 2, step 3, step 4. Step 1 is equal sign. If you're teaching an elementary school student, it's a number sign. Think of the number that goes on the top. But for me, it's an equal sign or a double underline. Step 2 is multiply. Step 3 is subtract. And step 4 is bring down. So you double underline the first. It's actually the one with the highest exponent in the inside and the one with the highest exponent on the outside. So I need to try to figure out what to multiply by to make it equals. So step 1 is basically saying x times what equals 3x. I'll write that in red. X times what equals 3x. That's really what I'm trying to figure out. So what's the answer to that? X times what equals 3x? What do you think? Yep, 3. So I'm going to put a 3 on the top. And usually that's the first time through. And so you're going to have to do it more than once. But in these, you only have to do the long division process one time. So it's kind of interesting. Okay, so you multiply that. 3x plus 3 So I did the multiplication, and then the minus means change the signs. You're distributing a negative sign. So you distribute a negative sign, distribute a negative sign. I try not to make my pluses look like minuses. You know, when some people just overwrite the plus and make it a minus, I find that doesn't work very well. So it's better if it's just actually a minus. Okay. And then you subtract, which basically means change the signs, and then add the column. So this is 0, which should happen, and then this is 2. Okay, and then when we're writing our answer in the numerator, we have to put a plus because it's algebra. And then what goes in the numerator? Do you remember what goes in the numerator from the last problem? Yes, so 2 goes in the numerator, and then what goes in the denominator? Yep, x plus 1, perfect. So when you write it, usually we write it as the 2 over x plus 1. And then if this middle sign was a negative, it would be negative 2 over x plus 1, but that's fine. And then plus 3. So this is our answer, changing the form. And then we're ready to graph it. So step C. What way would I be moving this one? What are the 2 ways I would be moving this one? So up 3, I agree. And then what else? And left 1, I agree. So left 1. So up 3, left. And this is the tricky part. What is the basic equation? What do you think? What's the basic equation? Yes, exactly. 2 over x. Exactly. Perfect. So the basic equation is 2 over x. So let's make a table. If it was negative, it just ends up in different quadrants like yesterday. So this is 2 over negative 2, which is negative 1. 2 over negative 1, which is negative 2. 2 over 0, which is undefined, which makes an asymptote. 2 over 1 is 2. 2 over 2 is 1. And then for those of you who don't remember where I got those, I'm basically substituting these numbers into the basic equation. And then over means divided by. So this actually means y equals 2 divided by x. So I don't usually write it that way. That's more the elementary school of writing it that way. But sometimes when you're working it out, it helps. You think 2 divided by negative 2, and then you can write negative 1. So the elementary school way of writing it is absolutely okay. We just converted to the line division instead. But there's no reason why we can't go back. So 2 divided by, so I didn't fill in the rest of my table. So this is a 2, and then 2 divided by 2 is 1. So let's graph those. Those numbers aren't too big. And which way are we moving it? Up 3, left 1? Okay, so we don't need to prepare too much for our graph. Label the asymptotes and graph. Okay, so let me graph here. Oh, and remember I wanted to write at the bottom that we have another asymptote at 0, at y equals 0. All boomerang graphs have 2 asymptotes. The one where it's undefined, and then also the one where you also get y equals 0 for an asymptote on the. So let's see. So negative 2, negative 1, negative 1, negative 2. 0 is an asymptote. I'll write that in green so we could see it. So that's an asymptote. Positive 1, 2. Positive 1, 2. And then positive 2, 1. Which would look like a creep. I mean, I have no idea how to connect these 4 points, make a rectangle or something. But I have to memorize that the ones that look like 2 over x, 7 over x, when there's one x in the denominator, an x plane, not an x squared, it's going to look like this. And even the ones like 2 over x squared might look a little bit different as well. But kind of the same. They still have the boomerang kind of idea. There's just not opposite quadrants when it's 2 over x squared. So it's kind of interesting. Anyway, and then I need the other asymptote. So the other asymptote is the x-axis. Oops, I didn't. That's cool. My pen, when I hit the button, it erases. That's so cool. Wow. Okay. Anyway, I just found that out. Okay, so when I on my pen, I have a little clicker. And when I hit the clicker, it erases. So I don't have to change to erase. This is so awesome because I always change to erase and then I write with the eraser and then it erases everything. It's very annoying. Okay, so let me draw this one dashed. So here's my dashed boomerang graph. I wonder if the other teachers just call it the A over X graph. I'm really curious. I'm going to write myself a note that says, ask teacher friends. Ask what they call y equals 2 over x. Oh, that's weird. So all of a sudden it wants to take a picture. Okay, that's very strange. I don't know, maybe I hit it with my arm. Name. Okay, so it's probably because I'm hitting the maybe I'm hitting something on the pen. So now my pen's too thin. Okay, sorry about that. Back to here. Okay, and then I'm going to change colors. And which way we're moving it? Up and left. Okay, so the yellow asymptote, the yellow line here, moves left, but nothing happens when you move it left. So I'm just going to move it up. So up would be at 3 now. And horizontal asymptotes and horizontal lines are always y equals the number. So it's y equals 3. And HA is my abbreviation for horizontal asymptote. And then left 1 would be my blue, changes to left 1. And then I move all my dots. So left 1 up 3. Oops, change colors. Left 1 up 3. Left 1 up 3. And then left 1 up 3. Left 1 up 3. And the green is my new graph. And then I should make sure it doesn't hook like that. Mine wasn't looking like it was going towards the asymptote. I'm really not supposed to have it cross the asymptote, but I need to look like it's going towards the asymptote. And then that's horizontal asymptote. Oops, that's a vertical asymptote because it's a vertical line. So vertical line, x equals -1. If you hear that sizzling, that's because my mom's making some delicious dinner. That's okay. It's okay, Mom. Dinner's coming. That's way better than dinner not coming, right? So sizzle away. At first I thought it was water, and then I realized I don't think it's water, and I realized it was sizzling. And then I'm curious, so I just want to check the intercepts. So let me do that in in yellow, maybe. I don't know, maybe, I guess red. No, what color should I do this one in? Okay, I'll do it in orange. How about light blue, medium blue? Okay, so y-intercept is right here. And let's see if it's where I thought it was going to be. It's supposed to be at 0, 5. And did it turn out to be 0, 5? It did. So I might have been able to just see that one from the graph and not did the work behind it. And then they also right here, that's the x-intercept. And the x-intercept is at -1 2/3, 0. Yeah, I feel like that's kind of looks 2 to me, but that's only because of the way I drew the graph, but it's really close to -1 2/3. So, and the asymptote's there at 1/3. So the x-intercept, the y-intercept, and then the 2 asymptotes. And then I have my boomerang graph. Next. I would like to do one of the equations from the other day and find the intercepts only. And then that's when we'll be done. But I need to check back. So let me click back here. It was this one. So let me write down this equation. So what was it? Y equals 1 over x minus 2 plus 4. And then what was my other one? Y equals negative 2 over x plus 3 plus 1. Okay, so let me do both of those because we didn't do x-intercepts on those. So let me go back to where I was. Here we go. So in the time that we have remaining, which is about 7 minutes, let's just find x-intercepts for our equations from Tuesday. That's what I'm thinking that I want to do. Okay. And what was D? D was label the equations. So I have the equations labeled here. Okay. And how are we doing for speed? Are you caught up, or am I too fast? So are you done, or are you still making your graph and the labels? Just let me know when you're done, and then I'll get that to the intercepts. Okay, perfect. So let's check. Let's do this one. Okay, so now this is just x and y intercepts. So this is just intercepts for we called it what? DL9. So DL9's graphs. Okay, so let's see. Y equals 1 over x minus 2 plus 4. And then over here, we'll do y equals negative 2 over x plus 3 plus 1. Okay. So all we're doing left is just finding the intercepts for these, and then we'll be done for the day. So x-intercept, y-intercept. Okay, so x-intercept, y equals 0. So 0 equals 1 over x minus 2 plus 4. Y-intercept is x equals 0. So y equals 1 over 0 minus 2 plus 4. Usually I like the y-intercept better. The negative looks funny in the denominator, so I'm going to move it to the numerator or to the front. Now I need to add these fractions, but you know, fractions kind of panic people, but we can use negative FMDAF. What we can do is we can say they don't have the same denominator, but I want them to have the same denominator. So this one needs to have a 2 in the denominator. So I'm going to multiply the top and the bottom by 2. It's really like using my brother. 8 over 2. And then that's 7 over 2 positive equals y. And that would be 0, 7 over 2. And if I was going to graph it, I probably would want to know where that was. So that would be 0, 3.5. And that would be the y-intercept. And this would be an acceptable answer, but if you were graphing it, it'd be nice to know exactly where. What do you think about the x-intercept? I'd like to cross multiply, but that 4 is in the way. Is there any way to get rid of the 4 so I can cross multiply? I'd like it to make a proportion if I can, and the 4 is just kind of in a bad spot. So I can either I could move the 4, or I could do my brother right now and make them both have the same denominator. But I'm thinking I could just move the 4. I am. I'm doing my brother again, Mom. Okay. Okay, so how do I move the 4? Minus 4. What do you think? So minus 4 equals 1 over x minus 2, and now it looks like a proportion, so I don't have to use my brother. Okay, so multiply one way, negative 4 times x minus 2 equals 1 times 1. 1 equals, distribute, negative 4x plus 8, minus 8 minus 8, negative 4x equals negative 7, divide by negative 4, and we get x equals negative, oh, they're both negative. So a negative divided by a negative is a positive. So that's positive 7/4, which would be 7/4, comma 0, because that says x and y is 0. Or you can divide. So 4, at the bottom of my tablet, it really doesn't like to write. So 4, oh, I should have used my new eraser trick. Okay, 7, 1, 4, 3, so 3/4. So this is 1 3/4, comma 0. So it's good practice with the fractions. The only reason you would need to change it to a mixed number is if you wanted to graph it. Or, if you're taking a multiple choice test and you're trying to get the answer to match something that it says. Let me zoom out. I'll do this one. So x-intercept, y equals 0, 0 equals -2 over x plus 3 plus 1. And then I'm going to do the y-intercept, which is x equals 0. So you put a 0 in for the x instead. 0 plus 3 is 3. Need a common denominator. So I use my brother technique, right? I need the same denominator. So to get the same denominator, I'm going to say, okay, my brother has a 3, I need a 3, and then put it there. And this is just a regular fraction. So it's the same thing that you learned in elementary school. It's just I can use my brother terminology that we were doing in the other part of chapter 7. So 0 1/3. That's the y-intercept. We could check the graphs on the other page, but we're not going to. And then this one, I'd like to cross multiply, but I can't cross multiply because the 1 is there. So I can either do my brother, meaning the 1 needs an x plus 3 top and bottom, or I can say, I prefer to do it the geometry way, which is to solve it like a proportion. So -1 is -2 over x plus 3. And then I can do the cross multiplication. I like the solving it like a proportion. But you have choices. So -1 times x plus 3 equals 1 times -2. So that's -x minus 3 plus 3 plus 3. -x equals 1. Divide by -1. And x equals -1. So -1, comma, the y was 0. So 0. So this is the x-intercept. And that's the y-intercept for these. It's 5. I'm going to stop the video, and then I will write down the questions for the homework and upload both. That's going to take me a little while to do, so I'll try to do that by the end of tonight. Okay? Let's see. So let me stop the video. There we go.